Let's explore. Have you ever stopped to think about how all the different bits and pieces of our world connect and work together? It's a massive, wonderful puzzle. To make sense of it all, scientists like to put an imaginary box around a part of the universe they want to study. We call this special box a system. A system can be anything you can imagine, from something as tiny as a single cell in your body to something as enormous as our entire planet Earth. Everything outside of this imaginary box is called the surroundings. Thinking about the world in terms of systems and surroundings helps us understand how things interact and change, making big ideas much easier to wrap our heads around. It's like focusing on one puzzle piece at a time to see how it fits into the bigger picture. Now, let's get into the fun stuff, how these systems behave. The key to understanding them is to look at what they share with their surroundings. We're mainly talking about two things, energy and matter. Matter is the physical stuff that makes up everything, the water in a glass, the air we breathe, the trees in a forest. Energy is the power that makes things happen. It can be heat from the sun, the electricity powering your telly, or the chemical energy in the food you eat. By watching whether a system lets energy and matter cross its boundaries, we can sort it into different types. This simple idea is a super powerful tool for scientists, engineers, and curious explorers like us. Let's imagine you're holding a hot cup of tea. Your cup of tea is the system. You can feel the heat warming your hands, right? That's energy leaving the system and going into the surroundings, your hands and the air. You can also see steam rising from the cup. That steam is water vapor, which is matter, also leaving the system. Because this cup of tea is swapping both energy and matter with its surroundings, it's a perfect example of what we call an open system. It's not closed off, it's interacting freely with the world around it. Most of the systems we see in our everyday lives are open, constantly exchanging things with their environment. This concept of systems isn't just for science labs, it's everywhere you look. Your own body is an open system. You eat food, matter and energy in, you breathe air, matter in and out, and you release heat, energy out. A car is an open system. It takes in petrol, matter and energy, releases exhaust fumes, matter, and moves, work, which is a form of energy. By starting with this basic idea of a system as a defined area of study, we can begin to unlock the secrets of how everything from a simple pot of boiling water to a complex ecosystem really works. It's all about drawing a line and seeing what crosses it. So, let's dive deeper into open systems. As we touched on, an open system is like a busy train station with things constantly coming and going. It freely exchanges both energy and matter with its surroundings. Think about it, nothing is truly isolated. These systems are dynamic, always changing and responding to what's happening around them. The boundaries of an open system are completely permeable, meaning they let stuff pass through. This constant flow is what makes life on Earth possible and keeps our world so interesting and active. It's a continuous dance of give and take between the system and its environment. A fantastic real-world example of an open system is a forest ecosystem. Imagine a beautiful Aussie bushland. It gets energy from the sun, which plants use for photosynthesis to grow. That's a huge input of energy. It also takes in matter like water from rain and carbon dioxide from the air. At the same time, it releases things back into the surroundings. Plants release oxygen, animals breathe out carbon dioxide, and when leaves or animals decompose, their nutrients return to the soil. Matter and energy are constantly flowing in and out of the forest, connecting it to the wider world and the atmosphere. It's a perfect illustration of an open system in action. Let's think about the movement of matter in more detail within this forest. Animals like kangaroos move in and out of the forest's boundaries, carrying matter with them. Birds fly in, eat some berries, and then fly away, dispersing seeds far and wide. Water flows into the ecosystem through a river and flows out again downstream, carrying sediments and nutrients along with it. This movement of matter is a defining feature of open systems. It means the total amount of stuff inside the system can change over time. The forest isn't a sealed-off bubble, it's a living, breathing part of the larger landscape, constantly interacting and exchanging materials. Energy transfer in an open system like our forest is just as dynamic. The sun's light energy is transformed into chemical energy by plants. When a wallaby munches on some grass, that chemical energy is transferred to the wallaby, powering its hopping. As the wallaby moves, it releases heat energy into the air. This transformation and transfer of energy from light to chemical to heat is happening all the time. The energy doesn't just stay put, it flows through the system, changes form, and much of it eventually leaves, making way for new energy to come in. This constant energy throughput is what fuels the entire ecosystem. Now, let's switch gears and talk about the opposite closed systems. A closed system is a bit more like a snow globe. You can shake it up and see the glitter swirl around, but no glitter can get out and no new glitter can get in. In scientific terms, a closed system can exchange energy with its surroundings, but it absolutely cannot exchange matter. The amount of stuff or matter inside a closed system is fixed and never changes. Its boundaries are sealed tight against any matter trying to get in or out. While perfectly closed systems are rare in nature, they are a really useful concept for understanding some important scientific principles. A classic example you might even have in your kitchen is a sealed pressure cooker. Once you've put your ingredients and some water inside and locked the lid, you've created a closed system. As you heat the cooker on the stove, energy, heat, is transferred from the stove into the system. This energy makes the water turn into steam, increasing the pressure inside and cooking your food super fast. You can feel the heat coming off the sides of the pot, so energy is clearly being exchanged. However, the lid is sealed tight, so no steam matter can escape and no air matter can get in. The amount of food and water inside stays exactly the same from start to finish. In a closed system, matter cycles internally but never leaves. Inside our pressure cooker, the water changes form from liquid to gas, steam, and back to liquid again as it condenses on the cooler lid, but it's all the same water molecules trapped inside. No new matter is introduced and no matter is lost. This is very different from our open forest system, where water could flow in as rain and leave as river water. In a closed system, all the building blocks you start with are the only ones you have to work with. They can be rearranged, changed, and moved around inside the system, but the total inventory remains constant. Energy, however, tells a different story. It can cross the boundaries of a closed system in forms like heat or work. For our pressure cooker, heat energy flows in from the stove. The system uses this energy to do work by increasing the pressure inside. As the pot sits on the stove, it also radiates heat back out into the kitchen. So while the matter is locked in, energy is free to come and go. This is the fundamental rule of a closed system. Energy can be exchanged, but matter is on permanent lockdown. Understanding this helps us in fields like chemistry, where reactions are often studied in sealed containers. So why is it so important to understand the difference between open and closed systems? Well, this knowledge isn't just for passing a science test. It helps us understand and interact with the world in a much more meaningful way. In our daily lives, recognizing these systems helps us with everything from cooking a meal to understanding the weather. When you put a lid on a pot to boil water faster, you're partially closing the system to trap heat energy more efficiently. When you open a window to cool down a room, you're turning that room into a more open system, allowing heat energy and air matter to escape. It's practical science in action. In the grander scheme of things, these concepts are crucial for tackling some of the biggest challenges facing our planet. Scientists treat the Earth itself as a large, complex system. For the most part, it's a closed system when it comes to matter. Apart from the occasional meteorite coming in and rockets going out, the amount of matter on Earth is pretty much fixed. This is why we hear so much about recycling and sustainability. We can't just get more resources from somewhere else. We have to work with the matter we've got. The materials we use, from water to minerals, cycle through the Earth's systems, and understanding that helps us manage them responsibly. However, when it comes to energy, Earth is very much an open system. It constantly receives a massive amount of solar energy from the sun and radiates heat energy back out into space. This flow of energy is what drives our climate, our weather patterns, and powers nearly all life on the planet. Understanding this energy balance is the key to climate science. When we add greenhouse gases to the atmosphere, we change how easily energy can leave the system, which causes the planet to warm up. Thinking of Earth as an open energy system helps us model and predict these incredibly important changes. From building more efficient engines to designing sustainable cities and protecting our global environment, the principles of open and closed systems are fundamental. They provide a framework that allows engineers, biologists, chemists, and environmental scientists to analyze problems and come up with innovative solutions. So, the next time you see steam rising from a kettle or feel the sun on your face, you can think about the incredible transfers of matter and energy that are happening all around you. It's a simple idea with powerful implications, connecting your kitchen to the entire cosmos and making science a part of your everyday world.